We talk a lot about Star Wars on this podcast. Some of us even have their own Star Wars podcast, which I'm not going to plug right now and anger my co hosts.
But you
And
did
Star
say
Wars is science fiction. You're welcome, Jake. And Star Wars is science fiction, but, technically it happens in the past, a long time ago in a galaxy far, far away. But people who are into it are kind of into the future. And that is all of us, as well as our guest, Alex Kass from Accenture Labs. We're going to dive into all sorts of things about the future of learning on this episode of The Learning Geeks, starting now. Okay, hey everybody, welcome.
hey.
Hey, nice to be here.
Glad to have you, Alex. It's always great. You know what? I got to tell you guys, this is kind of funny. I love the way that when we have a guest on, they engage at the beginning, because I was just listening to, I think it's the Severance podcast, and somebody was saying about how whenever they're on a podcast, they're usually like sitting there pretending like they're not there for 15 minutes while the hosts do the banter that nobody cares about before they bring them in.
Skips. Yeah.
But we like having our guests join in from the beginning. So welcome, Alex. We're glad you're here.
My son and I have just started watching Severance.
Oh.
We watch about 2 episodes a week, catching up. We're still on season 1, so no spoilers.
No
please.
spoilers. It is so good. Second season has been really, really good so far. And
that's going to be my next show, because I wanted to catch up. I didn't get to watch season 1, so that's my next.
Yeah, good stuff. It's a little close.
Didn't even know there was a show called Severance, so I'm gonna.
All right,
that's
Dana.
how far behind I am.
All right, Dana.
Dana.
It's on Apple TV.
But I have enjoyed my severance since I left Accenture.
Well, this is a different kind of severance.
Exactly.
See, I was curious when Bob was talking about severance. Saying, "Oh, let's go."
Yeah. Now we're going down a different path that we probably shouldn't go down right now. Dana, would you like to more formally introduce our guest, our old friend Alex here?
Yeah, we don't normally do formal things, so I'll do an informal intro of Alex.
Informally formal. Yeah. Great.
So many years ago, I won't say about that many years. I walked into the Institute for the Learning Sciences at Northwestern University. It was a program that I was asked and was excited to participate in, and I met Alex Kass. And Alex was one of our mentors when I was there, and I came back to work for Accenture, and Alex went some other way after he left the Institute. But then he came and joined Accenture, and I was so excited because I always learned so many things from him and from the other colleagues of his that were teaching there. And then I really got excited anytime I'd visit him in his office, because he always had gizmos and gadgets that looked like nobody else had access to. Somehow, in his work at Accenture Labs, he was able to get, and it was one of those things where you walk into a kid's room and there's little toys laying around. Well, it was very similar to walking into the lab, because there'd be Oculus headsets there or other headsets before they were available
Oculus,
to the before they were available to the open market, and they were just sitting around. Like, what did you do with that? Well, we experimented with that one, and we're trying this one, and then really enjoyed when they would actually produce some prototypes to see the types of things they were doing. So Alex and I have kept in touch throughout the years, and I'm excited. When Alex, for your information, when Bob and Jake and I were kind of talking through the schedule, I said, I'm connected with Alex. I'm sure he's got some good insights on stuff we could share. And Bob and Jake immediately said, yeah, let's get him on. So glad to have you here, Alex. And you, as I understand it, you're part of Accenture Labs, and you run the digital experience part of that, the digital experience lab. So what did I miss, Alex? What should our audience know?
No, thank you. Well, I mean, you're on target in terms of the gadgets. I like to, sometimes I describe myself when people are asking about my background as a reformed academic and a startup refugee. I started, I'm a computer scientist by training. I started by studying AI. And I was going down the sort of pure research path. And I realized at some point that most of the people going down that path, they played with gadgets just so they could get their papers published, or mostly so that they could get their papers published. And that I was getting my papers published so that I could play with the gadgets more, and so that I was really a lot more interested when it turned out to get a little serious here about although the theory of AI is remains really fascinating to me as part of a whole sort of interest in cognitive science. Um, my interest really has been, my passion has been for how can we leverage technology to make people and organizations smarter,
Hmm.
whether that involves using AI and making machines smarter or using other technologies like extended reality or robotics or biosensing and neurosensing, which is something I hope we'll get to talk a little bit about because some of my colleagues in our group here are really fascinated with that and finding some really exciting applications. Um, but yeah, I'm really interested in uh, topics at the intersection of technology, cognitive science, and human learning. And the group we have at Northwestern, I'm sorry, Northwestern is where we
Flashback.
met,
Yeah,
and
yeah,
so
yeah.
I'm thinking
Sorry, I
the
threw
group
that
we
one
have
at you.
the group we have
Go Cats.
at Accenture is it's called Digital Experiences. It really is within Accenture Labs, which has a number of different R&D groups looking at all different kinds of emerging technology. We are the human-centered computing, human interaction team within Accenture Labs. We're kind of at the, if you think of a technology stack, we sort of sit at the top or with the part that touches the user the most. We're interested in transforming the learning experience and the work experience more generally, also the consumer experience and how we buy and how we use products after and supporting the customer experience after the purchase. And we're really interested in the design process because it crosses both of those. How do products and experiences get designed more effectively, and how can we use technology to improve that? So
And Alex,
that's the basic idea. And I'll just say one more
yeah.
thing because I'm really proud of this aspect of it. The group brings together people like me who are sort of computer scientists and AI scientists with people who have very different disciplinary backgrounds in cognitive and neuroscience and human machine interaction. And it's that combination that I find really
Hmm.
makes the work exciting and differentiates us from what a lot of other folks are doing.
And Alex, I was also thinking that Accenture Labs, and I know you're active part of this, is also often responsible for what Accenture takes to the CES each year, right?
Correct. Yes.
So
We
lots of
definitely have
crazy
we definitely
stuff
have
out
a
there.
marketing function,
Yeah.
and that's where we're trying to show off sort of cool new technology. But also one of the things we try to do, frankly, is be the skeptics. So we show off cool technology, but our first thought is let's get this technology in and see how cool it is. But our second thought is, okay, it's cool when you first play with it. Will it still be cool after you've been using it for a long
Yeah.
time? And
Yeah.
beyond that, is it actually useful?
Yeah.
And what will it take to make it useful? So that's one of the things I like to make sure people understand about the labs is there's different kinds of labs. Some labs are really about product testing
Hmm.
and validating that the product does what it says it does, and we do some of that, but we're the kind of lab that cooks things up as well. So we start with getting some of the technology in from our technology partners, hardware, software companies around the world, but then we try to say, okay, what do our clients need? Can this help? And what do we need to add to make it really useful to meet those needs? And that's so we're an invention shop as much as an assessment shop, or maybe even more than an assessment shop.
So you started in your little discussion about this. You mentioned neurosensing. I'm wondering if we want to start
Yeah,
there. Maybe you want to give a brief idea of what neurosensing is, and then how can it be used by people in the learning profession, or how might it be used in that way?
sure, sure. Let me actually zoom out even slightly further
Yeah, yeah.
first. I don't want to stay abstract too much, but I do like to give the sort of uh, establishing shot, to use movie terminology. Um, this idea of like our mission is about creating smart tools and products that can help transform the way we work and live and learn and create. And that stays fairly stable from year to year. But then what changes over time is what technologies we're exploring. Uh, and right now, we really have four technologies that we are sort of focused on. We'd like to do 10, but we don't have enough people, so we pick our bets. And the four, obviously AI's got to be one of them these days, but we really don't. There's another group in labs that does AI. So we only look at AI when it's at the intersection of how users will be interacting with AI. And we look at AI in combination generally with other technologies. If it's a pure AI application, yeah, we might leave that to others, but when it involves combining the latest AI, for instance, with the latest sensing technology,
Hmm.
so you can sense the world but also
Hmm.
make sense of what you're seeing,
Yeah.
that's really interesting to us. So we have four areas, and I'll just lay them out for you, and we'll dive into one or two of them. Biosensing probably be one of them. So one is human AI agent interaction. How does the world look different when your teammates include both colleagues like they do now, human colleagues, but also AI colleagues, AI assistants, and how will AI have to change when it has to interact more with people or with other AIs that may be part of your company or other companies, so forth. Another is multimodal XR. So beyond the headset to what does XR look like when you have audio only input, for instance, and you're not just using it when you wear a headset. A lot of what we focused on within XR lately is moved away from VR to AR and into what I call intelligent AR, again, with the idea of combining AI with a device that sees what you see, is able to interpret it, is able to coach you, for instance, transforming how you do your work every day because you have a coach that can interact with you. Um, then a third part, and those both, by the way, relate a lot to learning. We'll get to that as well, and to training, and I think the learning geeks should be interested in those. And then a third one, I guess, less focused on learning is agile robotics, and how does the latest capabilities of AI, how is that going to really change the way robots can interact with people? And then the fourth is this intelligent biosensing and applied neuroscience. So, yeah, I just wanted to set the context and give you a sense of, because a lot of the things we might talk about later in the session will involve combinations of these. So I don't want to just dive into it
This is
in a
this is
as a silo.
this is kind of like my first day at ILS. Wow, he's using a lot of big words.
Oh, I'm sorry. I didn't
No,
mean to be
no,
doing
no.
that. I'm just trying to let people know we look at a bunch of technologies and then treat them as building blocks and try to think about how they can combine to solve real problems. So, one of the key problems that we're interested in is how is technology going to transform the way people learn?
Yeah.
And that's obviously, I think, what you guys are interested in talking about most today, and it's one of my passions, obviously, as well. Um, and we really believe pretty strongly that, first of all, that the life cycle of learning you have to think about not just how do you develop the most effective training, but also think about how do you make sure someone's ready to learn when they sit down to take that training. And after they've taken the training, um, how can we ensure that they are retaining what they've learned and refreshing, and that they have support while they try to apply it. And so, um, we're interested in how the technology can assist with both before, during, and after. And one so to sort of move through that a little bit, um, one of the technologies that's advanced a lot in the last few years is neuro and biosensing. And we use that term pretty broadly. Mostly we're talking about wearable sensors now. Simple one being like the watches that a lot of us are wearing now that are actually sensing us a lot of the time. Or I don't happen to have one on right now, but the rings, a lot of my colleagues are now wearing rings, yes, that
Yep.
monitor their sleep. The other technology, and I should have brought one as a prop, I'm sorry I didn't, are various headgear now that can actually measure your brain activity. And that technology has really advanced pretty significantly in the last several years from being something that was really, hundreds of thousands of dollars kind of equipment that's usable, that's really suitable only for a clinical environment, high stakes clinical environment, to now where you can have devices that are $20,000 that are very robust sensors that they have both electrical and physical isolation of the sensor so you can be moving around and they still work, or you can be wearing other devices and they'll still work. The electrical interference won't get with them. And so these are all new ways to sense the world and new ways for our systems to sense us, which combined with AI, so you have new ways to sense, and then you have AI that's new ways to make sense of what's being sensed.
Mm-hmm.
And then in combination with that, in those two things, uh, there are a number of applications we're exploring, which are basically around the system is able to understand the user and react to them more effectively. So getting back to learning, uh, let's start in the middle. Although I'd love to be able to talk about you know uh, the before, during, and after. Let's start with the core, which is training. Uh, when I was at ILS, as you probably remember, we thought we were building the best stuff anyone, and the same at Cognitive Arts. We were pretty convinced it was the best. We knew it was probably a little too expensive, which is why the company ran into trouble. But we were, and I think still are, convinced that for the time it was the best. But did we really know it was the best? We didn't, to be honest with you. Nobody really had at that stage a really good way to determine, was a learning design really effective? And especially you might be able to test afterward whether it was effective in the big picture sense of, like, were people better able to pass a test, or hopefully even a more realistic assessment, are they better able to do a particular job function after taking the training? But you probably had some parts of it that were good and some parts of it that weren't good. Some parts where the learners were getting bored, some parts where you were going too quickly through things or asking them to do things that were too far beyond their ability. So they were either working too hard or not working hard enough, or it was you thought you were being funny, but they weren't actually finding it entertaining, or all kinds of flaws. And you didn't know which parts worked and which parts didn't. That's something we're trying to fix with what we call uh, learning neuro design studios. Okay, where what we're doing is creating a suite of applications that, these are at the prototype stage. I want to be careful to not oversell them. They're not, we're not going to put them out in the store um, now, but we are using them for real. Uh, where combination of a couple of different sensors. For example, one application we're looking at now involves a combination of a camera that can detect a camera and then a system that can detect facial expressions
Hmm.
with neurosensing. We found
Wow.
that neither works as well as we want on their own, but when you combine the two, you get some pretty good, we get like 20 different parameters that we can measure in, like, 1 second increments. So for instance, cognitive load, how hard are you thinking? But also um, engagement, to what extent are you paying attention, not? And also, especially from the facial expressions, uh, we get a lot of information that correlates with emotional responses. Are you feeling joy? Are you feeling fear? Are you feeling stress? Are you feeling nervous, etc.? And what we are working on is using machine learning, being able to really go beyond what even the vendors of these products are delivering directly, to be able to detect, uh, to separate the signal from the noise and be able to really get reliable readings of what was a test user experiencing when they were experiencing something you had designed for them, and did it match your intentions. That could be that thing you've designed for them Could be a physical thing like the cockpit of a car when you're trying to redesign the interior of a car, and we've talked to some of our clients that do that about that, or an entertainment experience. We've talked to some of our clients that about that. And our passion, of course, is for learning experiences. And can we get back to the kind of learning design activities that I used to do for a living, but equip the designers with something that really puts their claims to the test, and they think they did something great. Well, okay, how great was it? And maybe it was great for some audiences like them. That's why they think it's great. But other audiences that they're also trying to reach, it sucked. And, it was too hard, or was too easy, or it was too much listening and not enough doing, or, all kinds of ways that designs can run aground. We want to be able to get uh, really good input to the design. It's great to give designers input that allows them to do what they're doing now uh, better, and to have more accelerate the design process, be able to generate high quality content, whether it's exercises or presentations or whatever, faster. But I really think that's just the early stage. Okay, I like to think of it as three stages of impact we're going to have through the combination of things like neurosensing and AI. The first stage is do what you do now, but just do it faster and cheaper, right? Automate some of
Hmm.
it, etc. The second phase is what I've been talking about, where, okay, it's not just faster and cheaper, but you're actually going to produce higher quality because we're going to be giving you objective uh, feedback about how well your design works with a lot of temporal granularity. So not just did it work overall or not, but exactly at what point did you lose people, and what worked and what didn't. But the third, and the one I think is most exciting that we're really just on the cusp of now, is where the actual content you're creating, we're going from creating content that's where we're designing exactly what the the simulation will consist of, what the simulated characters will do, what the AI, what the digital tutors will do. We're going to move from that to what I think of as dynamic content, where the system is not just designed better, but it is going to be customizing its behavior directly because it's able to detect you, again, using the kinds of sensing that we were talking about, and it will be able to change its behavior on the fly. So we're not going to design something better. We're going to design something that is customizable in real time. So if Dana is really smart about a particular topic and Alex doesn't know as much about it, it will go faster for Dana and slower for Alex, or vice versa, and so forth. I think that's really the future that that we need to keep an eye on and be pursuing, as we, it doesn't all happen at once. So I think each of these phases is important, and we look at all three of them. Um, but but I think that getting to that dynamic content phase is really important.
Yeah. We've talked about that in the past, Alex. The with the advent of AI, the first thing that happens is the good, fast, or cheap pick two triangle kind of goes away because you can get good and fast and cheap by today's standards, which means that to really differentiate, now you got to go even deeper down one of those things. And I hear you saying it's the quality there that is going to be the biggest impact. And then we're gradually going to see more and better learning experiences until it's a bespoke environment for, it's whatever the one person needs to best learn what they need to learn in that moment.
Right.
That's the future we have to look forward to, which is really exciting.
I think customization is really exciting, and it's been the bane of industrialized education, the lack of customization for a long time. So it's really exciting. I also think of it maybe even slightly broader terms, that this is about a world in which our machines are able to interact with us in a more human way. That one of the things that I see that makes me a little bit annoyed is I see folks who are marketing digital humans that are human in the sense that they look very photorealistic simulations. They're avatars that I think that's exciting, by the way, as the technical side of me is like, wow, that is amazing. But another side of me thinks is this kind of little bit of an uncanny valley in an abstract sense, in the sense that no matter how realistic it is, like as I'm talking now, I'm seeing Bob is nodding his head.
Mhm.
Dana looks interested when I'm in general when I'm yeah, exactly. When I'm talking to an audience, sometimes I start to get a little bit nervous because I can see people are starting to fade, and I adjust my behavior, right? And if it's one-on-one, I'm starting to see if I said something that made you a little sad. I hope I can be sensitive to that, and our digital systems are not. Our our robots are not. Uh, our AI tutors are not. And so the ability to sense the user in my mind is also about creating a more human interaction. And as machines start to play a larger and larger role, having that be something where they are acting in a way that is more sensitive to who they're interacting with and creating a more human-like experience, um, even though we're interacting with machines more. I think that's really an exciting aspect of this whole thing.
So, Alex, one of the things when I think of humans, especially when we're around each other, let's say physically, there's a lot of sensory data that we ourselves are gathering while we are talking, our environments, our smells, the way we, what we see and so forth. And then it makes me think of the sensors that you just talked about from, let's say, our watches or maybe the neurosensors and so forth. And you mentioned how on its own, like one sensor itself wasn't super effective. It was when you combined multiple. Like, can you talk a little bit about like what made only just the one sensor not work so well? And then what's the power of the combination of multiple that I think can really generate some really effective insights from machines, again, to provide some useful insights for us, would be
Sure.
interesting.
Well, I mean, and I don't want to oversell how much we understand about this yet. We understand some things, but there's still a lot to be learned about that, about even how does a human combine the various things they're sensing. But let me just give you one example of something we were experiencing uh, this week, as we're trying to do one of these prototypes where we're having uh, I can't describe all the details because it's
Ah,
proprietary
come
You can tell
on.
me later. You
application.
can tell me later.
Yeah,
Yeah.
sure. But I'll say in the abstract that it's about as an audience is experiencing something. Let's say it was marketing material, which it's not, but it'd be a good example. Um, how are they reacting to it? Is it having the impact on them that was intended by the people who created it? And one of the things we found was that some people, when they feel some joyous reaction to it, as we kind of determined from the asking them how they felt about it and
Mm-hmm.
so forth, people who seem to have felt the same way, nevertheless, their facial express, some people are very broadly expressive. Some people less so. It may be related to gender, it may be related to age, it may be related to whether they've had Botox treatments, it may
Cultural
be related
differences,
to a lot of
cultural
Yeah.
neural
changes. Yeah.
differences.
Yeah.
Um, and so the facial expression on its own is just one piece of data. Now, if you've interacting with someone over a long period, you may be able to calibrate to their specifics. But I think what really helps is if you have multiple sources of data. So, for instance, if I have the neural signals and the facial expressions, maybe also, we haven't actually done this recently, but if we also have, say, heart rate and things like that from their watch, now we can start to see, oh, you know what, we get certain patterns from this person that correspond to when they're feeling a certain way in their facial expression, and a different pattern from that person, but we can tell from the other signals that seems to relate. And now we can start seeing the small smile means the same thing when one person makes it that the big smile means when the other person
Mm-hmm.
makes it.
So real quick,
And so that I think that's does that answer your question, or was that
no,
did I answer a
it
different
really
question?
does. It really does because it honestly, even when I think of facial censored data or facial data, I think of there often is a lot of bias. Even in humans, we do a lot of guessing, especially for people that we
Oh,
don't know, right?
absolutely.
I
Yeah.
look at if
Yeah.
Bob, I might have a better idea. Dana, maybe not as much because he's a guy that sometimes smiles and then you don't know what he's thinking, But I know these guys more, but with someone I don't, I'm doing a lot of guessing of
Yeah.
someone.
Yeah.
I
So
wound up doing a lot of like I was literally just on a meeting with somebody where I was like, Kathy, I cannot read your facial expression. It
yeah,
looks like you hate everything I'm saying. Is that right? And
Yes, it is, right? I hate it
I
all.
mean,
yeah,
yeah.
she did.
Even my wife Erica talks about how usually her first impressions with people think that she's annoyed at them when really she's curious, she's listening, she's more of a listener at the beginning, and that
Yeah.
comes across a different
And
way.
and I think if you talk to people who are on the spectrum, for instance, autism spectrum, they'll tell you that that's a serious issue for
Sure.
them. Is people have to calibrate to them
Mm-hmm.
before they understand what their emotional reaction is, because it's not the same as everyone else's. So we want to be sensitive to that as well. Yeah, one of the things that I wanted to get out about this is that we're working now to make these systems as good as people are, but I don't really see necessarily that's the limit. Um, I don't see any reason why a system won't be better than humans at being able to read you and your emotional reaction. That's one of the things we're working on is how to use machine learning to really get as good as possible, and not just to imitate how people do it, but to decode all these signals and separate the noise. One of the guys on my team, his name is Adolfo. Um, his PhD was on analyzing uh, neural data and being able to reconstruct what someone was experiencing when they were experiencing that. Um, and so just because it's like a wow factor thing, I'll mention the specific thing he was looking at was music.
Hmm.
And he got to the point where he could, you know, play a bunch of songs for you, let's say a set of 10 songs for you, have you listen to them a bunch, record your neural activity while you were listening to them, and then later when he played one of the songs just by looking at the neural activity that he could detect while you were listening to the song, he could tell
Hmm.
which song you were listening
Amazing.
to.
Yeah.
Um, and I think that's just a first step. We started looking at that with regard to images as well. And it's an exciting. There's some ethical questions and privacy concerns that raises as well. And this is going to have to be handled very sensitively with regard to those issues and make sure it's always done in a way that benefits the people that are being sensed and not in any way that's harmful to them. And that's a whole other conversation we can have about how we make sure we put the right safeguards in place. But I think there's a lot of potential benefits that we can get to when I call up a customer service agent now, I talk to a person when I can, but I know that increasingly it's just the way things go. I'm going to be talking to machines. I'd like to make sure that machine can tell when I'm frustrated the way the human can tell when I'm frustrated now. And I think unless we start doing this kind of detection, it's not going to happen. And especially getting back to learning, which I know is what your audience and what we are really most passionate about. An instructor that is not I'm not resonating with the way they're trying to explain something, or the exercise they're giving me, I can't quite understand how even to get started. I want them to be able to sense what's going wrong. It's not that I'm bored, it's that I'm working too hard and I can't quite grab it on, or the other way around. It's not that I'm working too hard, it's that I'm bored and they need to go forward. I think that's really important. The physical manifestation of this that gets across to people a lot is when we talk about robotics. So I think there's an analogy to in things like a training system and with a robotic system. Robots are going to be increasingly working in spaces where people are as well, physical robots. Now, if I'm a person let's say I'm a big person and you're a smaller person, and I start coming toward you to bring you something, but I'm coming toward you a little too quickly, I'm going to notice in your face that you may be a little nervous that I'm going to not even see you and bowl you over. Uh, or if I'm coming too slowly and making you wait too much, I'm going to notice that you're frustrated with me about that. So I'm going to calibrate my behavior to your facial expression, to what I'm detecting about you. Robots don't do that right now. And robots are going to have to learn how to do that in order to interact with people well, so that if they see you're nervous, well, because they're going too fast, they'll slow down, and vice versa. That same thing's going to happen with learning systems. They're going to have to be reactive to you if we're really
Yeah.
going to take them as serious partners in learning.
Yeah. Well, hey, we are really at the end of our time. Alex Kass, I feel like we're just scratching the surface. So you are welcome back whenever you would like to
I
join
hope that
us.
was
It
helpful. I,
was,
I
It was
yeah,
great.
probably
It was great.
I probably spent more time speaking about things that were on my mind and less time actually trying to answer your questions directly. I'm happy to come back and answer anything you'd like to ask and talk about any of this stuff related to what we're working on, what you're working on. It was really fun for me.
That's great. Well, what's on top of your mind, I think, is interesting to all of us
Mm-hmm.
and to anybody else. So thank
Agreed.
you for
For sure.
doing that. So thanks for being here, Dana and Jake. Thanks as always. And to our listeners, thank you for tuning in. Hope that you got as much out of this conversation as we did. Stay tuned for the next episode of the Learning Geeks podcast, which will be coming real soon. Talk to you then. Bye-bye.
right.
Thanks, everybody.